Hello, good morning. So today we will deal with the classification section. So in machine learning, classification is the problem of identifying which category a new observation belongs. That is, if we are given a number of classes to which the incoming new inputs or new observations are to be classified, in classification it is a problem of identifying to which class the input will belong to. ഇപ്പോൾ നമുക്ക് ഒന്നോ രണ്ടോ ഔട്ട്പുട്ട് ക്ലാസ്സസ് ഉണ്ട്. ഒരു പുതിയ ഇൻപുട്ട് വാല്യൂ അല്ലെങ്കിൽ ഒരു പുതിയ ഒബ്സർവേഷൻ വരുവാണെങ്കിൽ വി ഹാവ് ടു ഡിസൈഡ് ടു വിച്ച് ക്ലാസ് ഇറ്റ് വിൽ ബിലോങ് ടു. സോ it can have real value variables or discrete variables depending upon the case. And in usual cases, if there are two classes, we usually refer to as a binary classification problem. And with more than two classes, we usually refer to as a multi-class classification problem. Then there is a case where a particular example will be labeled with multiple classes will be assigned with multiple classes, so that we usually refer to as a multi-label classification problem. That is, a single example will belong to more than one class, so that is a multi-label classification problem. Usually there are different classification algorithms available, and some of the well-known algorithms are listed in this slide. Next, so let us see an example. Here we have given score 1 and score 2 of certain students and their marks in those in two exams and the results, whether they are pass or fail. So there are two attributes, score 1, score 2. The class label is the result with possible values of pass and fail. Now we have to, what we have to do here is we have to decide if a new value, a new score is coming in, we have to decide whether the person is pass or fail. That is what I said. When a new value comes in, we have to decide to which class he belongs to. So the result has two classes, pass or fail. So we have to decide which class he belongs to. So this is a plot showing the input attributes score 1 and score 2 and the given values pass and fail. Pass is marked as black circles and fail as the white circles. So if a new value, say the square, comes in, we have to decide whether the person is pass or not. So the problem of finding this rule or formula or the method is the classification problem. So here there are different methods by which we can classify whether the student is pass or fail. One method is we can say score 1 plus score should be greater than or equal to 60. Then he will be pass. Or we can say score 1 he has to score greater than 20 and for score 2 he had to score greater than or equal to 40. In that case also he will be pass, otherwise he will be fail. Or another method is that we can just assign this using a variable and then iterate and find a best possible value or estimate the value using some other methods. For example, score 1 plus score 2 greater than or equal to m, score 1 greater than m1 and score 2 greater than m2. Then they will be pass, otherwise they will be fail. Now consider another example where a finance company will lend its money to its customers. So they have to decide whether to lend money to the customer, to the potential customer or not. So for that they are considering two cases. First is the annual income and second is the annual savings of the customer. Let x1 be the annual income and x2 the annual savings. So here what we can do is, one rule is that if x1 is greater than theta 1 and x2 greater than theta 2, then low risk, otherwise it will be a high risk. And another method is we can give it as an equation. So that is x2 minus 0.2 x1 greater than 0, then low risk else high risk. So this x1 greater than theta 1 or x2 greater than theta 2. And this is what we refer to as a discriminant. Discriminant is actually a decision surface which classifies the different classes, different output classes. If we have two output classes, whether give loan and not to give loan, we have to find a decision surface between these two classes so as to decide where to put the new values coming in. So that is the discriminant, and if you are expressing that as a function, we usually refer to as a discriminant function. So that is what we saw here. Discriminant is a classification problem, is a rule or a function that is used to assign labels to new observations. So next is decision surface. It is decision surface nu parayunnathu, it is a plot of the discriminant. So the plot shows how a fit machine learning algorithm divides the input feature space by class label. Decision surface nu parayunnathu, it is the plot of the discriminant. Okay, it is a tool for visualizing the classification model. So here each input feature will have a feature space. Earlier we saw the classification problem of the pass and fail students. We drew that x-axis and y-axis are the input features, score 1 and score 2. Similarly, each input feature will become one axis. And so what happens if the two axes are there, we will be having a sample space or feature space of two-dimensional feature space. And if we have more than if we have three axes, it will be a volume and three-dimensional volume, and if more than that, it will be of higher dimensions which we will not be able to represent on paper. Okay, so here it is the idea is to classify the incoming values into new classes and based on this discriminant. So we have to visualize how this is done. That's the purpose of the discriminant tool. So this is an example of where there are two input features. For these two input features, it is usually represented as R square. R square is our feature space, and here to classify a two-dimensional space, we just need a single line. So this line is referred to as a hyperplane. And for a three-dimensional space, here we denote it as R3, where 3 denotes the number of input features or the number of dimensions of the feature space. So for a three-dimensional space, we'll be using a two-dimensional plane for classifying the classifying into different classes. So usually it will be if it is an R cube or R raised to n feature space, then the hyperplane will be of dimension of dimension n minus 1, that is 3 minus 1. Here it is a two-dimensional plane. Here it is a single dimensional line. So hyperplanes, we can say, are decision boundaries that help classify the data points. Okay. Now moving on to the Bayesian theorem that we will see in the next class. Thank you.